Talofalava and welcome, boys and girls. I know that it has been really hard for you guys, especially with your studies, given the global crisis that we and our country is facing. So we hope that you are all in good shape and ready to learn something new out of this lesson, and even a recap of some of the topics that you have already been covered, that you already covered in the first few weeks of school. Our lesson for today is based on our Year 12 Geography curriculum. And so let's have a look at our learning outcomes. 1. Define the terminologies associated with geographical processes. So this is our process that we're going to look at today, geographical processes. And also, 2. Give examples or provide examples of this geographical process. Okay, let's look at process on its own. A process is a sequence of related events which result in clearly measurable and identifiable outcomes. Ia, o sa te taingala lea uma ona tapenaina. Lea tau te wawa ai mai ei. O le process lea ta ua le convection currents. Ia, e ise taimi e whaalau te leina i lea vaenga. Ai, o le ua mai pea e whaima whaatai tainga. Memo mua, convection currents is caused by the intense heat from the Earth's core, which heats up the rocks outside it. Okay? Ono no winga o le core, the inner core and outer core. O whafo anela, ia, o bela sia, ma amata loa o na raisanga i lunga. This heating process causes these rocks to rise and move upwards, or move up towards the surface. These heated materials or rocks, when reaching the lower part of the surface of the lithosphere crust, when it cools down, ia e whapena huila ia lea ona toe taamilu ma toe alu ngai lalo. Lea lai ei ia a una e tote wa ai toe tamaiti. Okay, let us have a look at this video. It's going to talk about the Earth's spheres, or the Earth's physical systems.
Earth is kind of like a puzzle. And I don't mean a puzzle like, where did my brother put my hairbrush? Or what exactly is in the tacos they serve on Taco Tuesday? I mean that our planet is made up of 4 very different parts that all work together to make Earth the lovely place that we know it to be. We call these parts spheres, and between them, they contain all the stuff on our planet. Everything from the fish in the ocean to the air we breathe. Earth has 4 spheres: the geosphere, the biosphere, the hydrosphere, and the atmosphere. So what exactly are the spheres? And what's in them? Let's take a look at 2, the geosphere and the biosphere. Up first is the geosphere. Geo comes from the Greek word for ground. You may have heard this before in words like geology or geography. It basically means having to do with the Earth. And in a way, the geosphere is kind of like the skeleton of our planet. All of the other spheres are built on top of it. It's made up of all the rocks and minerals on Earth, from the biggest boulders to the tiniest grains of sand. And all of the landforms that those rocks and minerals make up are part of the geosphere too. I'm talking volcanoes, canyons, beaches, mountains, you name it. If it's made out of solid Earth, it's part of the geosphere. Now, it's important to remember that the geosphere includes only non-living stuff. Living things do need to eat though, and all living things are part of another one of Earth's spheres, the biosphere. Bio is Greek for life, and like geo, you've probably heard it before in words like biology, the study of life. The biosphere is made up of many different biomes. Biomes are regions that have similar kinds of plants, animals, and other living things that have adapted to live in that particular region's terrain and climate. Deserts and forests are types of biomes. So are rainforest, grasslands, and wetlands. All of these biomes and many more make up the biosphere. Okay, now that we know what's in these 2 spheres, let's put them together and try to figure out what belongs to which sphere. Imagine a lovely forest meadow, a bird perched on a rock chirping away, a deer standing in the tall grass, a mountain standing tall in the background, and a stream flowing through the clearing. Ah, I can almost smell it. Almost everything in this scene is part of either the geosphere or the biosphere. Let's see if we can figure out which parts go into which sphere. Let's start with the geosphere. We know that there's nothing alive in the geosphere, so we can rule out all the plants and animals. Water is also part of a different sphere, but we'll talk about that later. When we take away the living things, we're left with all the solid earth parts of the scene. The rock the bird was standing on, the soil the grass was growing out of, the mountain in the distance, and the bed the stream water flowed through. So what we're left with is the geosphere. Rocks, soils, and landforms. Got it? Now let's think about the biosphere. Unlike the geosphere, everything in the biosphere is alive. So the rocks, the mountain, and the stream, they don't count. Now we're just left with the living things, the grass, the birds, the deer. Voila! You found the biosphere.
That was one but very informing video. I hope you guys enjoyed that, but watch this other video and see what you can learn from it.
I said that because the first sphere we're going to talk about is the hydrosphere. Hydro comes from the Greek word for water, and all of the water on Earth is in the hydrosphere. This means that every single drop of salt water in the oceans, but also all of the fresh water in lakes and rivers, is in this sphere. And it includes all of the water trapped in glaciers as ice, and the water held deep underground. Now, there's also water in the air around us, too, which we can sometimes see in the form of rain and snow. Those things come from clouds, which happen to be way up in the atmosphere. Our last, but certainly not least, sphere. This sphere contains all of the gases on the planet, which is fitting since atmos comes from the Greek word for air. Although we can't really see the atmosphere or grab onto it, it reaches everywhere and covers the entire planet like a giant snuggly blanket. But our atmosphere blanket isn't all the same. It's split up into many different layers. The troposphere is the lowest layer. It contains 80% of the air on the planet. It's also where all of our weather takes place. Above the troposphere is the stratosphere. There's no weather up there and much less air, but there's still important gases in it that help absorb harmful rays from the sun. The mesosphere is the coldest layer of the atmosphere and sits on top of the stratosphere. There's almost no breathable air up there, and even less in the thermosphere above it, where you might bump into some satellites flying around the planet. The last layer of the atmosphere is the exosphere. That's the highest you can go and still be on Earth. Once you leave the exosphere, you're officially in space, baby. Now, these two spheres can be kind of hard to tell apart, so let's investigate at the beach. The beach is the perfect place to take a closer look at what pieces of our environment make up the hydrosphere and which are parts of the atmosphere. The beach is, of course, right next to the ocean, and since the ocean holds most of the water on our planet, it's the biggest part of the hydrosphere. The rivers that flow into the ocean are also a big part, and so is the rain that's just starting to fall on our beach. Well, that's a bummer, but check this out. While the rain is a part of the hydrosphere, the clouds it came from are actually part of the atmosphere, and the wind that pushes the waves around is part of the atmosphere too. Even though we can't see it, the atmosphere is all around us in the form of the air that we breathe.
Okay, having watched that video, we should now have a fair idea of the different spheres of Earth. And we can say that all these spheres are interrelated and are interdependent of the other. The main concept that we are looking at here is interaction. Interaction is the relationship amongst these spheres. Okay? So it's really important to know these interactions. Okay, we're going to have an activity. We're not going to do the whole activity, but I'm just going to briefly go on it, and then if you have time, so you do it on your own and see how it goes. Okay, in the activity, as you can see, there is a diagram. On that diagram, it represents one of the four spheres that we already watched that video earlier. Okay, the first one is climate, second one relief, soil, and then vegetation. As you can see, there are 12 arrows. ia the key term le pe ono ta'ua ole interaction. Yeah. So it's like a representation of the relationship amongst the different spheres. Okay, we're going to talk about relief and climate, or point A and the environmental system at point B, or physical system at point B, which are one, climate, and then B, A, climate, and then B, relief. Vaengala ye lua lela tatu tamwhai. Se au titi loi. Ia pula ase so ta inga o yai nei vaenga o se o manga. Okay, relief can be defined as the features or the landscape of a certain area. Ia, nei ia le ata lea. O watu maunga, ia, o ngai mai I nofuanga maululunga, ia pea ngai e tui lalo nofuanga lafu le muma ma nofuanga maula lalo, I se o vaenga e maululunga. O fo ringa lao le lau whanua o Samoa, ia, o le relief o ina Samoa. Okay, some technical terms, conditions of a region, which one would be the temperature, the air pressure, the humidity, the precipitation, the sunshine, the cloudiness, and winds throughout the year. Yeah, they can be averaged over a series of years, which ole climate na. So if you have time, please go and find out the definitions for the terms temperature, pressure, so forth. Le tuti wa ai mai on the screen. A relationship between climate and relief. Yeah, o le ata le tuti titila tuai. O atu nuu ai sama atu nuu peo continenta, the continents. So at high altitudes in these continents, causes freeze thaw, which result in erosion, which modifies relief. Masui ai fo ringa wa aia o atu maunga ia manofuanga maulunga o nei atunu na fua ona o le malulu, which is the climate. Ia e mawhai ona malulu ma alu tausanga fia, geologic time. Ia ma fua ilo ona ta e ia tūlanga I maa. Masui ai fo ringa wa aia. Okay, so now we're going to talk about the physical processes taking place in geology. Wa ia geological processes ia e ngā lulu e whaatasi ina ia mauai ia ni pāteni po patterns. Patterns ia o fōlinga wa aia e mwhai on tātou whaingofia no mai ta wina. Okay, geological comes from the word or the term geology, which means the study of earth, the materials which it is made up of, and the structure of those materials, and the processes acting upon them. Let us look at the Earth's structure using these steel diagrams. So whenever you come across an image that's been cut, and then you have a horizontal view of it, you view it from the side, just the same as this diagram. That's called a cross section. Okay, so the layers of the earth, we are going to start looking at it from the inside out. The core, which is the innermost part of the earth, is very solid and very dense. The outer core is fluid. Lona luai, or the mesosphere, also known as the lower mantle. It is made up of large amounts of magma. Yeah, this is the result of the intense and immense heat from the core. Asthenosphere also known as the upper mantle, is made up of soft and plastic materials. As a result of these immense pressures and immense temperatures, very high temperatures, ia on mafu angana, ia e alai ona pie e whaongai nai upu e whaamtala ai le material le mau e tutonu vaenga le lalai as being soft and plastic. Okay? And then we have the lithosphere. The lithosphere is the outermost part of the Earth's surface. Ia, nai pi nifi ia, nai whaingoa mai lunga o le ata, o le crust. That is a lithosphere. E lua lai tu ainga lithosphere, o le continental, male oceanic. But we'll come back to that. As if I wow belta to le songa. Okay, after the lithosphere, we have the biosphere. This is where all life is located. O lono winga, o lunga o whunga ele, ili mea o tātou whiola man nofo ai. Ia, o waenga leo o tātou, o le biosphere. Okay, so, o lunga atu lau tātou, we have the atmosphere. Ia le nata miti. O lea o le amata mata le tātou wata. O le tātou wata, ia whaatau tonu lawa le mea o tātou o iai. We are talking about the Earth's structure.
The face of Earth is continually shifting, influenced by a process called plate tectonics. Earth's surface, the lithosphere, is a mosaic of many plates girdling the planet like seams on a baseball. These plates drift on top of Earth's hot and slowly churning mantle, over time colliding, breaking apart, and grinding against each other. To understand tectonics, scientists look back only 200 million years.
$225 million years ago, our planet looked very different. All the continents were joined together in a single supercontinent called Pangaea. As the plates moved, this supercontinent broke up. New oceans formed as continents drifted around the globe. It's this that has created the shape of the world we know today. But the plates never stop moving. In the distant future, our continents will once again be reunited in a new giant supercontinent. It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move.
Yeah, o isi lang una pala ayo o mea tioi. Ia ele se me whaapo le tātou o fo linga na se ata whaawhingo fia nga. Ia, o ni mea o lo tutupu I lalo I vaenga le o le lalangi. So now we're going to look at an image that further, takes us into this to our journey here on geological processes. Ia le ata maiti tō bāwa ai atu iai fō ringa o le lalangi ua iai. Ia le ta ua Alfred Wegener o tectonic plates will drift apart. Ia le ala ua iai le current state le ua iai le lalangi. Okay, so convection currents are playing their part here. Yeah, o le wa matanta to o atu tono geological processes. Yeah, le o le o mafuanga le o titilo tato lata maiti. Yeah, le na watu mua fa taita inga. Yeah, le o toi au mai fo. O le si ata le te vai tuai. Yeah. O na te vai tuai. It's a cross section of Earth, and the image illustrates geological processes, which is or convection current. There are two kinds of lithospheric crusts or tectonic plates. The other one is oceanic and the other one is continental. That's on black and white. Yeah, on a continental plate that represents that on your right, and then you would have the oceanic plate on your left. Ngai pi kau valiuli. Nei au nai. Yeah, okay. O le atana oceanic plates. Okay, the differences. Yeah, e lo na se senga. o le continental e whaisi ma o le oceanic e mamafa o le mafuanga e a whalengo o le tulanga i le rock po le material na e tonu o papa maane lo po le fausi ai papa ne e lua o le oceanic, it's made up of very dense rocks. Composition is very it's combined it's made up of basaltic compositions. It's made up of new material generated from underwater volcanoes at mid-oceanic ridge. O le sidila lo tula i mai. O le ala le me tula i mai po ame tupu i le vao papa maane. O le ala me tula i mai pe afa pe o le float ma move.
Okay, let us have a look at the Pacific Ring of Fire. The Pacific Ring of Fire is a region that surrounds the Earth's Pacific Ocean, and it is known for its volcanoes and earthquake activity. Tatu wawai le ata le tamaiti, ia, o le Ring of Fire, po o le Rim of Fire, o lo o taamilo milo a ngai le Pasifika. O le taula inga la o le papa maa o le Pacific Plate. Ia, o ta ua lea o le Ring of Fire. O i, o lo o iai, o lo o tutupu ai, le tele o maunga mu mamafui. Okay? Okay. So one of the processes that occurs in this region, po le taula inga o papa maa, ia le la atatu o atu iai. O le ata mua le ata maiti. O swatai ta inga o le plate boundary lea, e ta ua o le diverging plate boundary. Po le sea floor spreading le tele tatu whaonga ina le tatu curriculum. What happens here is two plates moving away from each other. And when these two plates are moving away from each other, it allows magma to rise from deep within the earth and erupts to form new crust or lithosphere. Ia, o se whataitainga o features o le neivaanga lololangi, ia, e maua mai ai mea ta o mid-oceanic ridges. Okay? Mid-oceanic ridges, an example would be the mid-Atlantic, and the East Pacific Rise. Okay, they are located. The East Pacific Rise is located in between the Pacific Plate and the South American Plate, and the Nazca Plate. Le tau te wawa ai atoi. Ia, e alu ia le Nazca na i le tūtam tau, e alu Pacific na i le tūanga vale. Ia, o le tupu i le process lea, e kau o le divergent process. Another feature of this process is submarine mountain ranges. Form up by me ka o submarine mountain ranges. Ringa pe se atu maunga I lalo i le toele po lalo i le pito I lalo sami. Okay. So we also have volcanoes and earthquakes occurring at this boundary. Volcanoes are mostly effusive. The other process that we're going to talk about is subduction. Subduction zones, or destructive margins. This is when two plates with different masses come together, drifting towards the same direction. This usually happens when a continental and an oceanic plate collide with each other. The more dense oceanic plate and the less dense continental plate oceanic plate. Some of the features that result from this process would be oceanic trenches. Tongan Trench, Peru-Chile Trench, the Middle America Trench, trenches. They are the result of subduction process. Okay? Olesi feature tupu mai I vaenga lea. Ometa o island arcs. Island arcs are a chain of islands caused and formed by volcanoes. Like a perfect example is the Japanese islands. Reila tale tuti wapa e tui tamaiti. Okay? Volcanoes and earthquakes that occur on this side, on this area, are mostly explosive. Roinga malolosi. Explosive eruptions and violent earthquakes. Ne tele o na luluma fui e ia ole atunu po ele tele na vulnerable I ia to inga natural processes. Okay? The other one that we need to talk about is the transform plate boundaries. O ila e tele na tupu I le vaenga le when two plates move past one another. Okay? So when two plates move past one another, le yata ye tau te baba ai to itamiti, the other one going a different direction, benafo ilesi. But they move side by side. Okay? Example lao features in more mai we have faults. Like an example, St. Andreas Fault. Leila tale matamataita to le ati whanga le Dwayne Johnson. Ia ole e base mai lunga ole fault le I America. Some of the common features here, ia omomeo process here, earthquakes, which are mostly violent earthquakes. Okay, and then we have the collision zone. O leisi lei tu ainga process e tupu mai I vaenga le. When two plates with the same mass, they come together. Lono wina ufe to ai. Ole me tupu. Ele ngoto ilalo leisi papama, but they both intend to rise and elevate or move upwards. An example of a feature that results from this process, we have fold mountains. An example of that, we have the Himalayas. Leila tale tau te wawa ai toi tamaiti. O atu maunga ia, they mostly have the highest points on Earth. An example would be the tallest mountain, Mount Everest. Ia olo I tonu ole feto ainga nei o papama ia, which is a result of that collision. Ia o maua e loa ia the Himalayas, which is o ngā kongoa olo I ele maunga re ta o Mount Everest. Okay. And last but not least, hotspots. Hotspots is a stationary hotspot underneath the Earth's lithosphere with immense heat and pressure that enables the magma inside the Earth to pass through the surface, forming volcanic chains of islands. A perfect example would be the Hawaiian Islands. Yeah, the oldest island is the furthest away from the hotspot. Well, hotspot, yeah, ngayele youngest island. O ngā tonula o lo yaile location o le me tal hotspot. Hotspots don't usually occur along these plate boundaries. O le se ngal hotspots mai si mua wa le ia tatou tala noai. O hotspot in whaiona tupu I to tonu al papa ma e tasi. So it doesn't need two plates interacting or moving. It just happens pe a whaapea o iei se me whaapea ka o le hotspot I lalo I fo o le papa ma e tasi lea. Okay?
Tamiti, ia o se taumwhainga na, o tatou le songa na mo ni eso. But to wrap up our lesson, I know that we have already looked at defining some terms, like physical process. We looked at processes, we looked at physical, so forth. We also looked at identifying the spheres, or spheres, or spheres, and that in between these spheres there's interaction going on. Okay, we also looked at the Earth's layers, right from the core to the lithosphere and biosphere. We're going to get there in our second lesson, okay, but let's focus here. And then we also looked at some of the processes behind this, all this happenings, the geological process like continental drift. We talked about subduction zone. We talked about the stuff involved there, the terms involved there. We talked about divergent boundaries where seafloor spreading, as it's commonly named in our curriculum. We have ridges there and so forth and so forth. And then also the collision points where fault mountains form. Yeah, and hotspot. By now, you should have an answer right in your heart that we are and you are the student. You are part of this. You are sitting right in the middle of all of this happenings. Samoa is on the Pacific Plate, and the Pacific Plate, guys, is surrounded by the ring of fire. O i oro tupu ai maunga mu te tele pe ona o ta ua i le teimi ona o whātu i tato talo i ne subduction zone. Ia o i oro tupu ai o where i Samoa, o nahi i le o mamau tele tato. O no, e te tau on tato i loa vaenga nei. In our website, we have fact sheets, we have some links containing some of the content pertaining to our topic for today. And we also, have some activities. If you enjoyed, and I hope that you guys are going to be back with our second lesson. I hope we're going to cover the other two physical processes, all in good time, and time limitation that's an issue. But okay, stay safe. Remember to always wash your hands now and then, and stay safe. So far, so good.